Alright, in this video we're going to begin the creation of behaviors. We'll be setting up the base class for behaviors and creating a simple behavior to demonstrate a behavior working in conjunction with an actor. Now, to get everything kicked off, we'll start with the behavior class itself. So we'll go over here in our Solution Explorer and we'll add a new class. This class is going to be called Behavior. And inside of this class, before we move on to the class itself, we do need access to the types found in the XNA framework, so we'll drop in a using statement for Microsoft.xna.framework. Now, moving on to the behavior class, there are two concepts we need to have addressed inside of behavior. One is wait, and the second is an update method. The idea is that behaviors will, of course, be layered into all of our actors, and those behaviors will be assigned a weight value. That weight describes how much this specific instance of behavior is able to affect the actor's direction. So a behavior with a heavier weight will have heavier influence on the direction that the actor moves. Now we'll store this behavior by behavior as a protected field. So we'll make protected float weight. Now we'll set up a public constructor for our class, since we need some way of assigning the weights from outside of the class itself. Since we've assigned this to be protected, we can't instantiate and then gain access to this field. So what we'll do is we'll set up the constructor for behavior to require the weight, and that will allow us to set up the weight when we create the behavior. It also makes sure that we don't end up with a behavior with a weight of 0, and therefore being redundant. So again, we'll accomplish this using a public constructor. So we'll have public behavior, and we'll take in a float parameter called weight. Then all we'll do inside of this constructor is set up the weight field. So we'll say this.weight equals the parameter weight. Alright, that takes care of weight itself. Now we need to define the method that is going to allow the behavior to affect the actor's direction. And we'll do this using a simple virtual method. We'll set up our behavior class so that it will have its own update method. So we'll make a public method, virtual. We'll have a void return type, and we'll call the method update. Now, we need a way for this behavior to tell which actor it should be affecting. So we'll pass that actor in to the update method. So we'll actually make an actor parameter. We'll simply call this parameter actor. Now, in the base class for behavior, we're not going to have any actual functionality inside of update, so I'm simply going to specify an empty method body out to the right. The idea here is that since behaviors are going to belong to actors, the actor will just pass a reference to itself into the update method, and then that will be our link so that behavior can affect the appropriate actor. Alright, that's all we need to do to define behavior itself. Now we do want to create a very simple example to leverage the behavior class. So we're going to create the behavior that I'm going to term behavior constant. This is going to be a behavior that will cause the actor to want to move in a specific direction. So let's define this class here after our behavior class. We'll call this class behavior constant. Since the behavior is going to affect a specific direction, and this specific behavior is not going to change over time. Now, behavior constant is going to extend the behavior class, and then we'll drop in the braces for the class body. Now, I'll also note the fact that we're going to be creating all of the different behavior classes inside of a single code file. Since most of our behavior classes are relatively short, beginning with the base behavior class, we'll keep these all inside of one code file, and that will keep our solution much more simplistic. There's, of course, no reason you couldn't start extending these out into their own code files as necessary for things like larger and more complex behaviors. Now, to finish off our behavior constant, what we need to do is we do need to store a little bit of state inside of behavior constant. It does need to remember which direction it's trying to point the actor in. So behavior constant is going to have a private vector2 field called direction. Now, in addition to simply remembering this direction, it will of course also be important to set the direction whenever we create an instance of behavior constant. And now to make it less confusing as we go through behavior by behavior, we'll make sure that each behavior requires all of the necessary setup information as part of the constructor. That will make it harder to accidentally forget that a specific behavior has a specific field that is required for its use. We'll simply require all of this in the constructor. That means that behavior constant is going to need to specify a public constructor. So we'll have public behavior constant, and it's going to take in two things. First, it's going to take in a float for weight, simply so that we can pass that on to the base constructor and get our weight set up appropriately. But in addition to weight, we also need to remember a direction. So we'll pass in a second parameter, a vector2 called direction. Now we'll make sure that we do get our chain call to the base constructor. So say base, call that with the weight parameter that we had created earlier. Now we'll drop in the body for the constructor and make sure that we initialize the direction vector. So that will be this dot direction is equal to the parameter direction. All right, so all very simple for the constructor. Now we simply need to provide an implementation for our update method. In this case, since we're inheriting from behavior, we'll be overriding the base update method. So we'll drop in a public override to update. We'll erase our call to base.update since we know that here inside of behavior it's not actually doing anything. Now what we would like to have happen is each time the update method is called, we will affect the actor's direction based on the direction that we're storing, and we'll affect that using the weight value. So we don't simply set the actor's direction, otherwise it would snap to that direction in a single update. We want to affect it a little bit by bit, over time. So what we'll do is we'll take the actor that's being passed into update, we'll take that actor's direction, and we will increment it. So we'll say actor.direction plus equals a new direction. That new direction is going to be equal to this dot direction, the behavior's direction, times this dot weight. So we can now see that a weight of 1 would cause us to immediately snap to that direction. So what we'll be doing is we'll be working with, you could say, fractional weights, where if we said we had a weight of 0.1, then that would take many updates in order to finally reach this direction, since we would only go a percentage of the direction we're trying to go in each update. So that way we'll cause the effect to happen over time. All right, now that we have the behavior system well underway, including an example of a specific behavior, let's modify our actor class to be able to manage or contain behaviors. So moving into our actor class, we'll scroll up to the instance fields for our actors, and we'll add in a new field. We're going to have a list of behaviors for each actor, and it's this list that's going to allow us to contain multiple behaviors per actor, and that will give us the layering behavior. So we'll put together a public list of type behavior, and we'll call this list behavior list. And then we'll use a field initializer to create it. So behavior list will be equal to a new list of behavior. All right, now that we've got the behavior list so we can store behaviors in an actor, let's make sure that we take those behaviors into account when we're updating actors. So we'll scroll down here to our update method inside of actor. We'll jump in a few lines before we actually affect the position. What we'll do is we'll look through all of our behaviors. we'll make a call to update so that each of the behaviors will get a chance to affect our direction as an actor. Then once we have that direction, then we'll apply the newly updated direction to position. So the first thing we need to do is update all of our behaviors. We'll do that using a simple for each loop. So we can say for each behavior in behaviors, or rather behavior list. Then we'll have the specific behavior reference. And from that reference, we can call the update method. We need to pass in an actor to be affected. Since we're inside of an actor, we'll pass in this reference. And so that way, basically looking at ourselves here as an actor, we have one of our behaviors update affecting us. Now, since we're only going to have one statement inside of this loop, I'm going to take out the braces. And that will make the code just a little bit more compact. All right, now that we have run an update on all of our behaviors, we have to make sure that we carefully handle the direction that we hold. Since again, in order for this calculation to be applied properly, to take the speed into account, direction has to be a unit vector. And so far, nothing is guaranteeing that our behaviors won't cause the length of the direction vector to go above 1, or even to result in one less than, or a value less than 1. We need to normalize our direction vector so that, let's say we had applied 20 different behaviors, all with a value of 1, so now we had a vector that had a length of 20 instead of 1, we need to normalize that. Now before we normalize it, we want to make sure that it's greater than 0, so we don't end up with an undefined result. So before we try normalizing, we'll do a check and say if this dot direction dot length is greater than 0, then we'll go ahead and normalize it. So that's this dot direction dot normalize. We'll call the normalize method. That will take care of normalizing the vector, resulting in a unit vector. And of course, we'll only do that if we actually got a value back. So if we set up a behavior that wasn't causing any change and our direction was set to 0, we won't try to normalize it. All right, with our update set in place, this should have the idea of behaviors fully implemented inside of actor. Now we simply need to create and apply a behavior to our actor object. We can do that back inside of our game. After we create the leader actor, we can turn around and apply a new behavior. We can do that by taking our leader, looking at his behavior list, and adding a new behavior to that. For this behavior item, we'll create a new instance of behavior constant. Behavior constant is going to need two things: the weight for the behavior itself and a direction that we're going to try to point at. For a weight, we'll give you a value of 0.1. And for a direction, we'll specify a new vector 2. We'll give ourselves a value of 1 in x and 0 in y. This will result in a direction pointing to the right. And let me pull out one of these. Actually, let me add a final closing parenthesis, taking care of our behavior list call. So let's build and run the game and see what is being exhibited. So running, you can see, now watching this, since the effect of the behavior plays out over roughly a second's worth of time, we don't have much time to view the actor as is. So pay close attention to the demo as soon as it loads up. What we should be seeing is whatever random direction our actor spawns in, it will slowly turn to instead face the right direction. So if we build and run a few times, we can see that we started out pointing kind of in the upper left direction. We made a curving, or rather a curved motion, resulting in moving in the positive x direction. So even though it's very brief, we do in fact have a behavior that is being applied to our actor over time. You'll notice that, unlike before, we now always result in an actor moving directly to the right of the screen. All right, with that, we have the behavior class in action, an actual behavior created, behaviors integrated with actors, and a demo of one of the behaviors in action. So with that, that's going to wrap up this video.